Hi guys, good day. This is Teacher MJ, and our topic for today it's all about the trapezoid. So without further ado, let's do this topic. Now, a trapezoid, it is a quadrilateral with only one pair of parallel sides. So do not forget about quadrilateral. It means it is a four-sided polygon. It has four sides. And we are dealing right now with a trapezoid. A trapezoid, it has four sides. Now, the parallel sides of a trapezoid are called the bases. So once again, if we talk about parallel sides, this one, BC, okay, this line BC is parallel to line AD. You can write that in the form BC is parallel to line AD. Okay, BC is parallel to line AD. Same with right trapezoid, BC is parallel to line AD. BC is parallel to line AD. Same with scalene trapezoid. Now, the parallel sides of a trapezoid are called the bases. So this one, BC and AD, we call that the bases. So this one, AD, you can call it the bases. Okay, bases. Alright, so BC and AD are the bases. So this one, in the right trapezoid, these are the bases. BC and AD. Same with scalene trapezoid. BC and AD are the bases. The non-parallel sides are called the legs. So this one, CD and AB are the legs. So these are the legs. So this is the leg. This is the leg. Same with this right trapezoid and same with this scalene trapezoid. So AB and CD are the legs. So we can write that as, if your teacher will ask you to find the legs, so your answer will be BA, line BA and line CD. Okay, if your teacher will ask you find the legs, so your answer will be line BA. Okay, line BA and line CD are the legs. Alright, so the angles formed are called the base angles. So this one, this angle right here, this angle, angle A, angle B, angle C, and angle D, these are the base angles. Okay, base angles, angle A, angle B, angle C, and angle D. Okay, the base angles are formed connecting the legs and the bases. This one, A, D, angle C, angle B. You can call that base angles. Now, we do have types of trapezoid: isosceles, right, and scalene. Let's talk about this trapezoid. So let's talk about first the isosceles trapezoid. Now, in isosceles trapezoid class, from the word isosceles there, it means that there are two sides. Two sides are congruent. So this side BA, is congruent to side CD. Okay, do not forget about that. If you talk about isosceles trapezoid, same with isosceles triangle. If you still remember isosceles triangle, if you talk about isosceles triangle, so isosceles triangle, therefore this side right here is congruent to this side. That's the definition of isosceles triangle. Now in isosceles trapezoid, therefore this side right here is congruent to side BA. So if BA is 10, therefore CD, it should be 10 because that is an isosceles trapezoid. Alright, so what else? If angle D, the measure of angle D is equivalent to angle A. Okay, so angle A, if this is 70, angle D, it should be 70. If this is 120, this is just an example. If angle B is 120, therefore angle C, it should be 120 degrees. So do not be worried. Later on, we will try some examples to answer for this trapezoid. So in a right trapezoid, let's talk about right trapezoid. In a right trapezoid, there is one pair of 90 degrees angles. So meaning there are two 90 degrees angles. So this angle B and angle A, these are right angles, 90 degrees. So that's why we call that right trapezoid, because there is one pair of right angles. Okay, right trapezoid. Now in a scalene trapezoid class, there are no sides are congruent. So no sides are congruent, meaning the measure of angle A is different to the measure of side AB is different from side BC, different from side CD, and different from side AD. That's the definition there about the scalene trapezoids. No sides are congruent. Now let's focus this one, the isosceles trapezoid. Let's focus about the isosceles trapezoid because mostly in the book you are answering with isosceles trapezoid. Alright, so do not forget that if we put a diagonal line, this diagonal line right here, BD, is congruent to diagonal line CA. BD is congruent to CA because this is an isosceles trapezoid. Alright, now what if we say, what if the teacher will tell you, okay, the teacher will tell you, what if we cut this line AB, we cut it into half, we put another point, we have point E, and we cut this line CD, okay, this line CD, we cut it into half, we put another point, alright, and the teacher will tell you, what is the measure of line EF, okay, once again, this is point F, this is point E, and your teacher will tell you, what is the measure of line EF? Okay, you cut it into half, BA, you cut it into half, and you have point E. CD, you cut it into half, and you have point F. And the teacher will tell you, what is the measure of line EF? How will you get that? So, very easy, class. What if we say that BC is 10, and AD is 20, okay? BC is 10, and AD is 20. Very simple. To get line EF, simply add the measure of the bases, add it 10 plus 20, and then you divide it by 2. So that would be BC plus AD and divide it by 2. So if this is 10, this is 20, 10 plus 20, that's 30, divided by 2. Therefore, EF is 15. Okay, so that's it. That's how you get the line EF divided by 2. So same with right trapezoid. If the teacher will tell you to find this measure in the middle part, simply add the bases, divide it by 2. Same with scalene trapezoid. Same equation. Add the bases and divide it by 2. So that's it. That's the properties there about the scalene trapezoid. So let's try to answer trapezoid. So we have an example right here to further understand this one. So example number 1. So we have trapezoid A, B, C, D. So once again, class, do not be worried about naming the trapezoid. So you can write this A, B, C, D, A, B, C, D, or you can write this, it depends on you, class. You can write A, B, C, D as long as it is consecutive. Okay, it should be arranged. A, B, C, D, it depends on you. You can write this A, B, C, D as long as it is consecutive. So I have A, B, C, D. Okay, I put it like this, A, B, C, D. Trapezoid A, B, C, D. Now, name the legs. So the teacher asks you to name the legs. So once again, do not forget that the legs, these are the legs, line DA. This is, once again, class, this is an isosceles trapezoid. So the legs, line DA and line CB. So these are the legs. So your answer will be DA, line DA, and line CB. Line DA and line CB. Once again, the teacher will ask you, is it okay that you will put line AD and line BC? That's actually the same, class. That's the same. Okay? Do not forget that AD, this line AD is the same with line DA. That's the same class. Do not be worried. It could be interchanged. Okay? That's the same. Alright, so next, name the bases. So the bases, that would be line DC, the bases, that's line DC, and line AB. Okay, line DC or line CD, or line AB or line BA. Those are the bases. Name the base angles. So the base angles, this one, angle A, angle D, angle C, and angle B. So we have angle A, angle D, angle C, and angle B. Those are the base angles. Now, if angle M measures 70 degrees, so angle A measures 70 degrees. So if this is 70 degrees, angle A is 70 degrees, what is the measure of angle B? So do not forget, as I told you earlier, that if this is an isosceles trapezoid, if what would be the measure of this angle is the same measure with this angle. What is the measure of angle D is the same measure of angle C. So if this is 70 degrees, therefore angle B, it should be 70 degrees. So this is 70 degrees. Now if angle D is 105, so if this is 105, what is the measure of angle C? So if this is 105, therefore angle C, it should be the same, 105 degrees. Alright, so once again class, do not forget, if DA is, just an example, if DA is 10, therefore CB, it should be 10 because in a isosceles trapezoid, these two sides are congruent. Alright, so let's try one last example. What if we are told to find the x? Let's try a complicated example. So, alright, so let's try complicated example. So we have, if angle B is equals to 2x minus 6, okay, angle B is, this is angle B. Angle B is equals to 2x minus 6. And you are told to find, angle A is equals to 82. Okay, this is 82 degrees. Alright, angle B is 2x minus 6 and angle A is 82. So it should be 82 degrees. And you are told to find x. Find x. So to find x, so you already know, okay, you already know that the measure of these two angles is congruent, okay, is equal. Therefore, you can equate this one. So you can write this as 2x minus 6 is equals to 82 or 82 degrees, or 2x minus 6 equals to 82. Sir, why did you equate that? It's because we know that the measure of this angle is equal to this angle. So let me just write it. So this is 2x minus 6 is equals to 82. And to get the value of x, so you are told to find the value of x. So transpose 6 from left to right. It will change the sign for you to find x. So this is 2x equals 82. Now 6 is negative. You transpose that. It becomes positive plus 6. So this is 2x equals 82 plus 6. That is 80. 88. You divide it by 2. You divide it by 2. So x equals 44. So x equals 44. Even if we check that, 2x minus 6, let's check if we have the same answer, which is 82. So if x is 44, 2 times 44 minus 6. So 88, 2 times 44 is 88 minus 6. It should be 82. Same. So therefore, your answer is correct that x is equals to 44. X equals 44. Alright, so let's try another example. This one, number 7. Alright, so number 7. If angle C is equals to 2 quantity y plus 4, and angle D is equals to 116, what is the measure of angle Y? So this angle C right here, given, okay, angle C is equals to 2 quantity y plus 4, and angle D is 116, and you are told to find y. So you are told to find the y. Find y. Now do not forget class that angle D is the same measure with angle C. So you can equate that one. So you can write that 2y, or 2 quantity y plus 4 is equivalent to angle D, which is 116. You can equate this one. Sir, why we can equate? Because they have the same measure according to the definition of the isosceles trapezoid. That these angles right here are congruent. They have the same measure. So distribute 2y and 4. So 2 times y is 2y. 2 times 4, that would be positive 8 equals 116. To get the value of y, transpose 8 from left to right. So this is 2y equals 116 minus 8. So 116 minus 8. So that would be 2y is equals to 108. Okay, and divide it by 2 to get the value of y. So divide it by 2. Y is equals to 108 divided by 2. That's 54. Okay, so y is equals to 54. Let's check. Okay, let's check if we get 116. So from this equation, so 2y plus 4. So if y is 54, so 2 times 54 plus 4. So 2 times PEMDAS. Simplify first inside the parentheses. 54 plus 4. That's 58. You multiply it by 2 and you get 116. So therefore our answer is correct. So y is equals to 54. So that is 54. Y is equals to 54. Okay, let me write that. Y is equals to 54. Okay, so that's it. Let's try this one. Let's try number 8. Alright, number 8. If AC is 56, okay, AC is 56, line AC is 56, this one. Line AC is 56. And what is DB? Okay, you are told to find this one, DB. Alright, what should be the measure class? Could you try? That's correct. So if AC is 56, therefore DB, it should be 56. So DB is equals to 56. Because in isosceles trapezoid, the diagonals are congruent. So this diagonal AC is congruent to diagonal DB. So that should be 56. Number 9, if AC is 2x plus 10, okay, AC is 2x plus 10, this one, 2x plus 10, if AC is 2x plus 10, and DB is 4x minus 6, okay, DB is 4x minus 6, AC is 2x plus 10, what is AC? Okay, what is the value of AC? So we need to find x, and then we substitute to get the value of line AC. So find x. So we have, okay, AC is 2x plus 10. So AC is equals to DB. Okay, let me write this here. Okay, AC is congruent to line DB. So if AC is 56, AC is 2x plus 10, so 2x plus 10 equals 4x minus 6. So we transpose, once again class, we transpose 2x from left to right. Since if we transpose 4x from right to left, it should, the sign will be negative. Okay, this will be 2x minus 4x. And if we subtract 2x by 4 or 2 by 4, the answer is negative. So therefore, to make things easier, just transpose 2x from left to right. Okay, once again, because if we say that our answer is x equals 2, that would be the same with 2 equals x. This is actually the same class. Okay, so it depends. It depends on you. Okay, you can put x on the right or you can put x on the left side. Okay, this is the same. Okay, do not forget about that. X equals 2 is the same with 2 equals x. So therefore, in our equation right here, we just transpose 2x from left to right. To make it easy, to make it simple, and to make our answer easier, okay, because if we transpose 4x from right to left, the sign will be negative, and 2 minus 4x, 2x minus 4x, that's negative 2x. And you have negative 2x. It will be complicated for you. So just transpose 2x from left to right. So this, and 6 from right to left. So this is 10, positive 10, transpose 6 from right to left. It becomes positive. Equals 4x, 2x, transpose that from left to right. Change the sign. This is positive. It becomes negative. 10 plus 6, that is 16, equals 4x minus 2. That's 2x. Divide it by 2. Divide it by 2. So therefore x equals 8. X equals 8, but you're not yet done since you are told to find the side. You are told to find AC, and AC is 2x plus 10. Substitute 8 from this equation. So 2x plus 10. So 2 times x is 8 plus 10. So 2 times 8, that is 16 plus 10. So 16 plus 10, that is 26. So AC is 26. So this AC is 26. So that's our answer. AC is 26. So let's try number 10. Last example. We have last example. So once again, class, do not forget that this AC is 26. Alright, so let's try last example. Alright, so dB is equals to this one. dB, same thing. Okay. dB is equals to 3y plus 7. And AC is equals to 6y. This AC right here is equals to 6y minus 8. So dB is 3y plus 7. AC is 6y minus 8. So once again, equate this one because they have the same measure. So we can write that dB, dB is congruent to, or is equal to AC. Okay, line dB is equal to line AC. dB is 3y plus 7 equals AC is 6y minus 8. So same thing a while ago. We just transpose 3 from left to right so that our answer will be positive. Okay, so copy 7. So 7 will stay on the left side. 7 transpose 8, it becomes positive. This is negative. You change that into positive. Do not forget, once you transpose an equation with this equal sign, you change the sign. The copy 6y, then transpose 3y from left to right, minus 3y. So 7 plus 8, that's 15, equals 6y minus 3y, that's 3y. Divide it by 3 to get the value of y, divide it by 3. So 15 divided by 3, y is equals to 5. So if y is 5, find dB. So dB is 3y plus 7. So 3 times 5 plus 7. So 3 times 5, that's 15 plus 7. 15 plus 7, that is 22. So dB is equals to 22. So if dB is 22, AC, it should be 22. Okay, even if we check that, let's try to check. Let's try to check AC. If it is really 22, 6y minus 8. So 6 times our y is 5 minus 8. So let's check this one. AC, if this is 22. 6 times 5, that's 30 minus 8. That's the same, 22. Alright, so therefore our answer is correct. So what if, let's try last example. What if DA is E is the midpoint of DA, F is the midpoint of CV. You connect this line, okay, and DC is 12, AB is 18. You are told to find EF. So to find EF, just simply add DC and AB. DC and AB. So 12 plus 18, that's 30. Divided by 2, the answer is 15. So EF is 15. So that's it, class. That's how you solve for the trapezoid. So I hope you learned something new today. And if you like this video, do not forget to subscribe. You share it to your friends, to your classmates, and you have a great day. So if you have some questions, please do leave a comment so that we can answer that one. And goodbye for now. Bye-bye.